Ask a language model a question it does not know the answer to, and it will not tell you that. It will tell you something. Confident, fluent, and completely made up. We call this hallucination, which is a generous word for it. The machine is not seeing things. It is doing exactly what we built it to do. I want to show you why. Not the disclaimer version, where someone tells you the model is sometimes wrong and you should check its work. You already know that. I mean the actual mechanism. Because once you see it, the behavior stops being mysterious and, more importantly, you stop expecting it to go away. Here is the thing almost everyone gets wrong. A language model is not looking anything up. There is no database inside it. There is no encyclopedia it consults, no index it searches, no list of verified facts sitting in a corner that it checks against before it answers you. If you open the file, you would not find a single sentence written anywhere in it. What you would find is numbers, billions of them. They are called weights, and they were set by a training process that read an enormous amount of text and adjusted those numbers, very slightly, over and over, to get better at one narrow task. That task is this. Given everything so far, what word probably comes next? That is it. That is the whole job. Not remember, not understand, not verify, predict. Now that sounds far too simple to explain what these systems can do. And it is worth sitting with that discomfort for a second, because it is the honest position. A machine that only predicts the next word can write working code, pass professional exams, and explain your own field back to you in language you would use. Nobody expected that. The people who built it did not expect it. The reason it works is that predicting text well turns out to be very hard. To guess the next word in a legal contract, you have to have absorbed how contracts are structured. To guess the next word in a physics explanation, you have to have absorbed how physics explanations go. Push that hard enough, across enough text, and a great deal of the structure of human knowledge gets pressed into those numbers as a side effect. But pressed in is not the same as stored, and that difference is where hallucination lies. Let me make it concrete. Say you ask who won a particular chess match in 1997. The model does not go and find the answer. It cannot. There is nowhere to go. What it does instead is generate the shape of an answer. It has read a great deal of text about chess, about that decade, about famous matches, and the pattern is strong. Strong enough that the words which fall out of that prediction happen to be the correct ones. And that is the part people miss. When the model is right, it is not doing something different from when it is wrong. It is doing the same thing. The pattern was simply good enough that the guess landed on the truth. Most of the time it does. That is why any of this is useful at all. If the guess were unreliable in general, you would not be using these tools, and we would not be having this conversation. But now push it somewhere thin. Ask about a company with 40 employees. Ask about a paper that was cited 11 times. Ask about a person whose name is shared by 4 other people, 3 of whom are more famous. Ask about last month. The pattern is weak now. The training text had little to say here, or said contradictory things, or said nothing at all. And here is the crucial part. The model has no way to feel that weakness. There is no internal alarm, no signal that fires and says, "Careful, I am on thin ice here. I am reconstructing rather than recalling." The machinery that produces a confident correct answer and the machinery that produces a confident wrong one are the same machinery, running at the same setting. So it does what it always does. It produces the most plausible continuation it can find. It writes a company history that sounds like company histories sound. It invents a paper title that sounds like paper titles sound, with a plausible author, in a plausible journal, in a plausible year. And it delivers all of it in exactly the same tone it uses when it is right. Here is what that looks like in practice. Ask for a citation to support a claim and you will often get one. A surname, an initial, a year, a journal, a volume number, a page range. Everything in the right place, everything in the right format, and no such paper. The surname is real because surnames like that appear in that field. The journal is real because papers on that topic appear in it. The year is plausible because that is when work like that was being done. Every component is drawn from a strong pattern. The combination has simply never existed. That example is worth holding onto because it shows what the system is actually good at. It is not good at recall. It is extraordinarily good at format. It knows exactly what a citation looks like, the way you know what a phone number looks like without knowing whose it is. When the content runs out, the format keeps going, and the format is what makes it convincing. That is the uncomfortable part, and it is worth saying plainly. The confidence is not evidence. It is not a signal about anything. It is the default setting. We are very badly equipped for this. Everything in our experience of other people tells us that hesitation means uncertainty and fluency means competence. Someone who answers smoothly, in complete sentences, with specific details, has usually earned that fluency by knowing the material. That heuristic works on humans. It fails completely here, because fluency is the one thing this system is guaranteed to produce whether or not it knows anything. There is a second reason the made-up answers are so convincing, and it is worth understanding separately. The model is not trying to fool you. It is not choosing between telling the truth and making something up. Those are not options it evaluates, because it has no representation of which of its outputs are true. From the inside, if there is an inside, both feel identical because they are produced identically. Which brings us to the question everyone asks next. If we know all this, why has nobody fixed it? The honest answer is that hallucination is not a bug that somebody forgot to fix. It is the cost of the method. You cannot patch it out, because there is no separate module doing the making up that you could go and repair. The behavior is not sitting beside the useful behavior. It is the same behavior, seen from a different angle. The thing that lets the model write a fluent sentence about something it half absorbed is the same thing that lets it write a fluent sentence about something it never saw. That does not mean nothing can be done. Quite a lot can be done, and a lot of it works. It just does not work by removing the problem. The first approach is to stop asking the model to remember. Give it a search tool or hand it the documents and let it answer from text that is actually in front of it. This helps enormously, and it is why so many serious products are built this way. But notice what it has really done. It has not made the model more truthful. It has narrowed the gap the model has to bridge by guessing. The second approach is to train the model to say, "I do not know." This is harder than it sounds, because you have to teach it when to say that, and the training signal for that is genuinely difficult to construct. Push too hard and you get a model that refuses reasonable questions. Push too softly and nothing changes. The third is to check the output with something other than the model. Another model, a rule, a database lookup, a human. This is the least elegant option and often the most effective one. Every one of these is a way of working around the method. None of them is a way of changing it. And that distinction matters because it tells you what to expect. These systems will get better at this. They have been getting better at it. But you should not expect a version where the problem is gone, because gone would require something that works differently than this does. So what do you actually do with that? The most useful shift, I think, is to stop treating the output as an answer and start treating it as a draft. A draft written by someone extremely well read, extremely fast, and completely unbothered by whether any particular sentence is true. That is not an insult. It is a job description, and it is a genuinely valuable one, as long as you know what you are holding. There is one more thing worth naming, because it is the part that actually causes damage. The risk is not spread evenly across your day. It concentrates precisely where you are least able to catch it. When the model writes about something you know well, you spot the wrong sentence immediately. It jars. You correct it and move on, and you come away thinking the tool is broadly reliable with the occasional slip. But when it writes about something outside your field, the same wrong sentence slides past because you have nothing to check it against. The error rate did not change. Your ability to detect it did, which means your confidence in the tool is calibrated on exactly the cases where you need it at least. And there is a practical tell worth learning. The failure is not random across topics. It clusters exactly where the training text was thin. Recent events, small entities, precise numbers, specific citations, anything where being close is the same as being wrong. When you see those, check. When you are asking for something structural, an explanation, a summary, a way to think about a problem, the ground is much firmer. None of this makes the technology less impressive. It makes it legible. A system that compresses an enormous amount of text into a set of numbers and reconstructs plausible language from them on demand is a remarkable thing. It is just not the thing most people think they are talking to. It is not a librarian. It is closer to someone who has read the entire library once, remembers the shape of everything and the exact wording of almost nothing, and has never once been taught to say so. Everyone gave you the headline. Here is the long version.